Look up at the night sky. The sheer volume of stars above you outnumbers every single grain of sand on every beach on Earth. In our galaxy alone, there are 200 billion stars. Beyond our local neighborhood lie 2 trillion more galaxies, each holding billions of individual worlds. By pure statistical probability, that massive volume of planetary real estate suggests life exists in abundance. This animated equation visualizes a calculation formulated by astronomer Frank Drake in 1961. It multiplies the total count of stars by the fraction of those stars with planets, the planets sitting in a habitable zone, and the specific odds of biology and technology developing to estimate exactly how many advanced civilizations should exist right now. Because the universe is over 13 billion years old, and Earth's 4.5 billion years represents only a fraction of that history, older civilizations had ample time to rise. A species just a few million years ahead of us could launch self-replicating probes moving at a fraction of light speed to cross and colonize every star system in the Milky Way. 10 million years is a blink on a cosmic scale. Based strictly on the age and size of the universe, our entire galaxy should currently be filled with their light, their broadcast signals, and structural noise of ancient empires. Instead, the reality of what we observe contradicts the math. We look into a sky that should be blindingly crowded and find completely empty, dead air. We point instruments like this satellite dish out into the dark, searching for anything unnatural. Yet we have failed to detect a single anomalous radio signal, an irregular shadow crossing a star, or any artificial structure in space. In 1950, physicist Enrico Fermi recognized this severe inconsistency. He realized that if the numbers say intelligent life should be everywhere, and our instruments show they are nowhere, either our mathematical understanding of the universe is broken, or a specific force is silencing civilizations before we can hear them. This glaring contradiction between high statistical probability and absolute zero observational proof is known as the Fermi Paradox. This silence suggests a biological limit, a potential warning that intelligent life, by its very nature, might be short-lived. The first explanation suggests the universe is still chemically young. The heavy elements required to form rocky planets take generations of dying stars to accumulate, meaning Earth-like worlds only recently became common enough to support biology. This creates a hopeful scenario. Humanity is the vanguard, arriving first in a universe that is only now becoming habitable for complex life. The second explanation follows a much more dangerous evolutionary curve. It proposes that the moment a species develops the capacity to leave its home world, it often develops the means to destroy it. We see this dynamic on Earth, where rapid technological shifts and massive climate alteration move far faster than our biological ability to adapt. If this pattern holds true everywhere, the galaxy might be empty simply because every civilization eventually hits this technological wall and fails to survive its own intelligence. This diagram illustrates the Great Filter hypothesis. It plots the journey from a lifeless rock to a galactic empire and places an almost impassable evolutionary barrier somewhere along that path, a step so difficult that almost nothing survives it. We can hope that humanity has already cleared this hurdle. If the initial leap from basic chemistry to complex biology was the rarest event in the universe, then we have safely passed the filter, and our future is largely open. But there is an alternative. The existential threat may still lie in our immediate future, waiting as an impending test that our species has yet to face. If the filter is indeed ahead of us, it means every single civilization that came before us progressed exactly to where we are right now, and then they died. A fourth theory posits that civilizations purposely remain completely silent. They hide their locations because any species advanced enough to detect them might also be strong enough and hostile enough to destroy them. Under this assumption, humanity is currently blindly broadcasting radio and television signals outward into a predatory galaxy, acting like a lone creature shooting a flare into the dark to see what responds. The final explanation relies on the sheer mathematical improbability of our own origins. The complex, highly specific sequence of events required to produce intelligent life may have occurred exactly once. If we are entirely alone in the void, there is no ancient wisdom to discover out there, and absolutely no one coming to save us from our own mistakes. The ultimate value of the Fermi Paradox has little to do with finding alien life. It acts as a mirror, forcing humanity to closely examine its own trajectory and the decisions we make today. If we are early to the universe, our primary responsibility is to survive long enough to eventually become the elder, guiding civilization the cosmos is waiting for. If a great filter or a wall of self-destruction lies ahead, we are required to actively manage the threats we create. The way we handle artificial intelligence, the threat of advanced weapons, and our fragile planetary resources will determine if we pass the test. Humanity's current technological choices are the active, real-time trial of these ancient cosmic theories. We are proving, right now, whether a species can survive its own capability. Despite our best scientific models, massive arrays of telescopes, and decades of observation, the definitive reason for the silence in the night sky remains a total mystery. But the possibility that we are alone carries immense philosophical weight. It places the entire burden of conscious thought and history onto a single planet. Under that premise, every single memory, every scientific discovery, every act of courage, and every conscious thought to ever occur in the universe exists solely on Earth. In an empty universe, our survival becomes the singular, most important responsibility in the cosmos.